Uh, uh, this is Mukisa Samuel Owekitiibwa, and I'm presenting Explainable AI and deep transfer learning for machine learning and for maize diagnosis. So my name is Mr. Owekitiibwa. So the contents of presentation include the introduction, problem statement, up to the acknowledgement. Now for the introduction, this study introduces the use of explainable AI and deep transfer learning for the diagnosis of maize streak and maize leaf blight diseases. The goal of this project is to empower farmers to improve agricultural productivity by enabling accurate and efficient diagnosis of maize diseases. So these are pictures of maize leaf blight and maize streak disease. So in case you come across this in case you look at the picture of a leaf or you look at the maize leaf and then you see these symptoms, you know this could be one of those diseases. So for the problem statement, I'm going to represent it. I would have visually represented my problem tree, but I'm going to explain the problem statement is that the decline in maize disease has been caused by other factors, but mainly caused by maize diseases such as maize streak disease and maize leaf blight disease that normally they cause uh, the plant to the growth of the plant to get stunted and uh, which uh, which in turn leads to low or even no crop yields at all. This in turn results in food shortages, low employment rates for the people working in the farmers, then hunger, then low export rates, thus leading to slow economic development. So to ensure that sustainable maize production and enforce food production and enforce food security and prosperity, we must be able to diagnose maize diseases in the early stages of infestation. This can be done by only reliable and efficient methods such as deep learning techniques, that is to say, image classification. So when you go to the rated works are one of the people who have done some kind of research, who have done some research in the maize disease, maize leaf diseases is Cheng and Wan. So these people used they used the probabilistic neural networks and the image processing. So they used the support vector machine and artificial neural networks for the identification and categorization of maize diseases. So we also have another Chinese Xi Jiang, he used the tool, he used the global Google Net and the self-attain models, and its accuracy were 98 for the Google Net, 98.9 accuracy, and the self-attain model achieved an average accuracy of 98.8%. So when you go to our research questions, the research questions how can we perform experimental data analysis on the maize data set? How can we create and train an image classification model from scratch to detect maize streak and leaf blight diseases? What pre-trained image classification models will be chosen for the purpose of maize disease detection? How can we evaluate the three models to select the best one which can do the task of maize diagnosis? So another thing we need to find out what explainable AI techniques can we use to explain the selected model, and what platforms can we deploy our machine learning so that it can be usable by farmers and agriculture experts. So part of our objectives is that we are performing image data processing, pre-processing, and experimental data analysis on the main data set, and then create an image classification model from scratch and using transfer learning on pre-trained model like ResNet 50 and VVG19. So we have found that most. So another objective is evaluate the three models performance using we shall use recall, we shall use accuracy, use S1 score, then select the best performing model. Then our third objective is to choose the best performing black box model, then make predictions then find out how to estimate prediction through the use of explainable AI techniques. So we shall also deploy our model on a mobile application and also use a web-based application. This will be used website application will be used to interface with the database, because once a farmer takes a picture of a disease or health disease, we capture the data in database. So for us to interface the database, we shall use a web-based application. So we shall use Django to build such things. So our methodology, we shall use the data, then we go to data preparation, go to the data analysis, then design our model, then do some transfer learning, then evaluate the model, then do some model. After evaluating the model, we shall do the model explainability using LIME SHAP. We shall also use the we shall also deploy our model. So our data set our data set has 15,821 maize image data set, maize images. So it has so as I'm still continuing, as I'm still continuing, as I'm still continuing, I thought about the dataset description. It's composed of 15,000. It's composed of all those images. So we shall do some image data, image data, uh, shall do some image data pre-processing and exploited data analysis. So in this, we shall do some cooking the dataset to remove unusable or corrupt images, augment the dataset, increase its size and visibility, normalizing the data to ensure that the images are in consistent format and range of values, and also perform the splitting of the dataset into training and validation and testing dataset. So we shall also be able to develop this an image. We shall also design an image classification model from scratch. Then the model will be trained to recognize the presence of maize streak and the maize leaf blight diseases in images of maize plants. So I shall also do some transfer learning on the VVG19 and the REST-NET 50 as a baseline models. So this will be done to we shall add some layers on these models and do some fine tuning for the weights and batches of the model. So we shall do so I talked about I talked about the performance of the image classification model will be measured using various va- various metrics such as accuracy, precision, and recall. So we shall also shall also uh, the model will also be compared to the two pre-trained models like VG19 and Wasted 50 to determine which model performs the best on the task, recognizing metric and diseases. So the best performing model uh, will be selected based on its performance and on the evaluation metrics such as accuracy, the recall, and also the precision. So we shall also do some model explainability. We shall use sharp. We shall use laywise reverse propagation. We shall use lime. This one explainability will help us to determine which features does the our our black box model, which features does it use? Which figures does it use to predict that this is a maize leaf blight or streak disease? So that this can help us to, to retrain the model and to ensure that the model predicts what is right. and also to build trust among the professionals of the agricultural community and also the farmers. So we should also deploy our model on the mobile application. So here, the mobile application, the farmer will be able to use mobile application to take a picture of in case he suspects a disease, to be able to take a picture of that disease using a mobile application. Um, so so after so, so someone will be able to relay. Uh, So we shall deploy the our model on the mobile application so that someone can be able to to take to take a picture of any diagnosis disease of any leaf diseased leaf and ensure that it's either say the disease or it's healthy. So shall we use an external database to also be created, analyze the images from the users. So we shall also collect the data that someone takes a picture. The data will be taken to our database where we shall try to get more data about class about diseases and healthy uh healthy leaves of maize. So we shall also do some expected results. Expect accuracy to be high. We expect the F1 score to also be high. We expect to have a minimum loss, a very minimum loss. This also expect a high precision. We expect a high recall on expected results. So we shall also perform explainability. So we expect to get sharp values for the different features of the model, for the different features of the model, like age, something like that. Uh, Going to the conclusion, conclusion now. This developed intelligent system will be able to actually diagnose mistake and misleaf practices in images of maize plants. So these external AI techniques will allow us to clearly understand the model's decision making and providing valuable insight for farmers and agricultural professionals. So it is also anticipated that the deployment of the experimental model will also increase its accessibility and usage for 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 the users, allowing real time real time guidance on disease management and optimization for maize cultivation. So the performance of the model may be affected by various by different variations like in the quality and resolution of the images used for training and testing. Additionally, the efficiency, the effectiveness of the model may be limited by availability and diversity of dataset and may not generalize well other crop diseases. So our future works will extend the scope of the study to include other types of diseases that affect maize like rust and some wilt. This will allow us this will allow the model to be more released and applicable for farmers, especially for the maize farmers. So we want to also explore other image classification models and architectures which can also which will also be able to outperform our model. So we shall also consider incorporating the additional data, as you had said, like such as weather data and crop management practices to see if they have an impact on the model's performance. So these are some of the references, identification of cognitive diseases based on transfer learning and data augmentation. So this was done by Chang. So you also have our friend Xiang Zhang. So this person also did some addition using improved deep learning convolutional networks. So as we have seen and already works. So we want also to acknowledge Dr. Joyce Narende, the head of the I lab, for 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 granting us the opportunity, uh, and supporting us with the image data set. And we also support the AI. We also want to express our gratitude to the AI lab, Stoic lab team for allowing us to access, to allowing us to to use their data set for maize because they are the one who created it. So also thank Mr. Galiwango Marvin for investing this time and effort to guide us to do this research proposal project. Thank you very much.